Hello students, welcome back to your one and only favorite channel, Tomachang Tutorial. Myself, Kisan Kulum, and we are doing polynomials, okay? We are ready to go for exercise 7.3 because we have already completed exercise 7.1 and exercise 7.2 and also the remainder theorem. So please find the link below in the description and watch the video again to understand this chapter. Because to understand this chapter, we need to have a very clear knowledge of remainder theorem. So please understand the remainder theorem first. Find the link below in the description. Watch that video again and come back to this video. Okay, let's begin. First, let us read the instruction of the question and then we will proceed to solve the questions. Okay. By applying remainder theorem, let us calculate and write the remainder that I shall get in every case. This when x cubed minus 3x squared plus 2x plus 5 is divided by x minus 2, x plus 2, 2x minus 1 and 2x plus 1. Okay, 2x minus 1 and 2x plus 1. The question is, when this expression is divided by this, this and this and this, what will be the remainder in each cases? Okay. When this expression is divided by this, what will be the remainder? We are asked to find the remainder by the remainder theorem, by the method of remainder theorem, by applying remainder theorem. Okay, please keep in mind, we are not asked to find remainder by the traditional method of division like this: x cubed minus 3x squared plus 2x plus 5. If we divide this by x minus 2, this is our traditional way of division. X into x squared becomes x cubed, plus into minus is minus x squared into 2 is 2x squared, isn't it? So this plus, we must change the sign, minus, this minus becomes plus. So plus x cube and minus x cube gets cancelled. Minus 3x squared plus 2x squared. Opposite sign, we need to subtract. 3x squared minus 2x squared is x squared, isn't it? The sign of the greater number comes here, plus 2x. Are you getting the point? This plus 2x comes down. So now we need minus sign in the front. Plus into minus is minus. X into x is x squared. Now minus into this minus, plus x into 2 is 2x. So this gives, this minus sign changes to plus and this plus sign changes to minus. Okay, minus x squared and plus x squared cancels out. Plus 2x and minus 2x also gets cancelled out, and this 5 comes down here as remainder. This 5 is remainder. So when we divide x cubed minus 3x squared plus 2x plus 5 by x minus 2, we got the remainder 5. But remember, we are not asked to find the remainder in this way. We are asked to find the remainder by applying remainder theorem. And what is remainder theorem? Let me remind you once again. If fx is a polynomial and this polynomial is divided by x minus a, okay, suppose if fx is a polynomial and this polynomial is divided by x minus a, then x will be equals to, then the remainder will be equals to fa. Okay, how do we get this fa? We write x minus a equals to 0, or x equals to minus a. When we take to the right hand side becomes plus a. So when we put fa, we get the remainder of this polynomial. Okay, are you getting my point? When fx is divided by x minus a, the remainder will be fa according to remainder theorem. When fx is divided by x minus a, we get the remainder fa. How do we get this remainder? We must suppose the value of this polynomial to be 0, and from here we find the value of x and then we find fa. Okay, please find the link below in the description and watch the remainder theorem again to better understand this. Let's begin. Okay, let us do question number 1 first and then 2, 3, 4. Okay, let's begin from here. Let Here we have suppose x minus a equal to 0 and x equals to a, isn't it? Similarly, let x minus 2 equals to 0, or x minus 2 when taken to the right hand side becomes plus 2. Got it? Get my point? Okay. X equals to 2. That means 0 of the polynomial x minus 2 is 2, isn't it? 0 of the polynomial means we supposed or we assumed this polynomial to be 0. The value of this polynomial to be 0. X minus 2 equals to 0. We assume the value of this polynomial to be 0. So 0 of the polynomial x minus 2 is 2. Let fx equals to x cube minus 3x square plus 2x plus 5. Okay. Now remainder will be, according to remainder theorem, remainder will be f2. Remainder will be f2. Instead, since fx is this, so f2 will be, instead of x, wherever you see x, just put 2. Okay. I hope you are getting me. Since fx is this, so to find f2, wherever we see x, we just put 2. Okay. Now since this is x cube, we put 2 cube minus 3. Since this is x square, we put 2 square plus 2. We have 2 here, and this x is 2 plus this 5. 2 cube means 8. 2 multiplied 3 times. 2 2s are 4, 4 2s are 8. 2 square means 4, and that 4 3s are 12. This minus comes here, 12. Plus 2 2s are 4, and this is plus 5. Okay. Now let us add up all the positive number and subtract the negative one. 5 plus 4, 9. 9 plus 8 is 17. 17 minus 12 is 5, isn't it? 5 plus 4, 9. 9 plus 8 is 17, and 17 minus 12 is 5. And the sign of greater number comes, that 17 is plus, so plus sign, plus 5. So the remainder is f2, and the remainder is 5. The value of f2 is 5. Here also we got the remainder 5, but we are asked to find the remainder by applying remainder theorem, this theorem. Okay. When this number, this expression is divided by x minus 2, the remainder will be 5. Got my point? Okay, let's go for question number 2. Let x plus 2 equals to 0, or x will be plus 2 when taken to the right hand side becomes minus 2, isn't it? 0 of the polynomial, 0 of the polynomial x plus 2 is minus 2, isn't it? 0 of the polynomial x plus 2 means, 0 of the polynomial means the value of this polynomial we assume to be 0. So 0 of the polynomial x plus 2 is minus 2. Okay. So let fx equals to x cube minus 3x square plus 2x plus 5. Remainder will be, according to remainder theorem, this is easy, isn't it? Remainder will be f minus 2. Since fx is this, so f minus 2 will be, instead of x we put minus 2. X cube means minus 2 whole cubed minus 3. X square means minus 2 square plus 2, and this x means minus 2 plus, and this 5. I hope you are getting me. If the power is odd number, then the sign will remain minus. If the power is even number, then the sign will change to plus. Okay, remember this. cube means 8, and since the power is odd number, 3 is odd number, so the sign will remain minus. So 2 square means 4, and the power is even number, so this minus becomes plus. This plus into minus is minus. Since the power is even number, so the sign will change to plus, and this plus into minus is minus. 2 squared is 4, 4 3s are 12. Plus into minus is minus, 2 2s are 4, and this is plus 5. Now it is very, very simple. You add up this all 3 negative numbers and subtract 5. 12 plus 8 is 20, 20 plus 4 is 24, 24 minus 5 is 19, I think so, 19, and sign of greater number comes here, isn't it? I hope you've got this. When this expression is divided by x plus 2, when this expression is divided by x plus 2, the remainder will be minus 19. Okay, please take the screenshot. I'm going to erase this and we will move on to question number 3. Okay, question number 3. Let 2x minus 1 equal to 0. So x equal to minus 1, we take to the right hand side, becomes plus 1. 2 comes to the denominator. Okay, cross multiplication. Okay, now since 0 of the polynomial 2x minus 1 is 1 upon 2, isn't it? 0 of the polynomial means we assume the value of this polynomial to be 0. So in that case, x is 1 upon 2. So 0 of the polynomial 2x minus 1 is 1 upon 2. Let fx equals to x cubed minus 3x squared plus 2x plus 5. Okay. So the remainder will be f 1 upon 2, isn't it? F 1 upon 2. Since fx is this, so f 1 upon 2 will be, instead of x we put 1 upon 2, isn't it? Since fx is this, so instead of x, f 1 upon 2, we put 1 upon 2. 1 upon 2 whole cubed. This minus comes here. This 3 is already here. Instead of x, we write 1 upon 2. So we have square plus 2. Instead of x, we write 1 upon 2. And we have plus 5. I hope you are getting me. 1 cubed is 1 and 2 cubed is 8. 1 is in the numerator, so let this number be in the numerator itself. 2 is in the denominator, when cubed becomes 8, let the number be in the denominator. Okay, 1 square is 1, 1 into 3 is 3, and this minus into plus is minus. Minus into plus is minus, 1 square is 1, 1 into 3 is 3, and 2 squared is 4. This 2 and 2 can be cancelled. 5 plus 1 is 6. Sorry, plus 6. Okay, plus 1 and plus 5 is plus 6. Let us write 1 in the denominator of 6 and take the LCM of the denominators. So LCM of the denominators 8, 4 and 1 is 8. So 8 ones are 8, that 1 into this 1 is 1. This minus comes here. 4 2s are 8, 2 into 3 is 6. This plus comes here. 1 into 8 is 8, then 8 into 6 is 48. I hope you are getting me. 48 plus 1 is 49, isn't it? 48 is positive, 1 is also positive. So 48 plus 1 is 49, and 49 minus 6 is 43. So we got 43 upon 8. This is an improper fraction because the number in the denominator is lesser than the number in the numerator. So if the fraction is improper, we need to convert that type of fraction into mixed fraction, isn't it? So let us convert this. 43 divided by 8. 8 5s are 40. 3 comes down. So we write this as 5 whole. This 3 comes in the numerator and 8 in the denominator. So when x cube minus 3x square plus 2x plus 5 is divided by 2x minus 1. The remainder will be 5 whole 3 upon 8. Got this? Take this screenshot of this work. I'm going to erase this and we'll move on to the next question, that is 2x plus 1. Okay. Okay. Let 2x plus 1 equals to 0, or x equals to plus 1 when we take to the right hand side becomes minus 1, 2 comes to the denominator. I hope you got this. Plus 1 becomes minus 1 and 2 comes to the denominator. So 0 of the polynomial 2x plus 1 is minus 1 upon 2. Okay, let, it is very simple, isn't it? Fx equals to x cube minus 3x square plus 2x plus 5. Since fx is this, so the remainder will be f minus 1 upon 2. F minus 1 upon 2, isn't it? F minus 1 upon 2 will be the remainder. So instead of x, we put minus 1 upon 2. Okay? X cubed means minus 1 upon 2 cubed minus 3. X square means minus 1 upon 2 square plus 2. X means minus 1 upon 2 plus 5 plus 5. Okay, so 1 cubed is 1, 2 cubed is 8, and since the power is odd number, sign remains minus. So power is even number, sign changes to plus. This plus into this minus becomes minus. 1 squared is 1, 1 3s are 3, 2 squared is 4. This 2 and 2 can be cancelled. So plus into minus is minus, minus 1 plus 5 is plus 4. Got my point? Plus 5, and this plus into minus is minus, minus 1. Plus 5 minus 1 plus 4. So 1 is in the denominator. We take the LCM of 8 and 4. The LCM will be 8, isn't it? 8 1s are 8. That 1 into this 1 is 1. Sign remains minus, and this minus comes here. 4 2s are 8. That 2 into 3 is 6. Plus comes here. 1 8s are 8, and that 8 into 4 is 32. So we have two negative numbers and one positive number. Let us add up these two numbers and subtract 32. 6 plus 1 is 7, and 32 minus 7 is 25, isn't it? 25. I hope you got this. 32 minus 7. 32 minus 7. Minus 6 and minus 1 is minus 7. 32 minus 7 is 25. And the sign of greater number comes here, plus, divided by 8. And this is also an improper fraction because 8 is smaller than 25. The value of the denominator is lesser than the numerator, so this is an improper fraction. We must convert this into mixed fraction, isn't it? 25 divided by 8. 8 3s are 24. 5 minus 4 is 1. So we write 3 whole 1 upon 8. Got it? So we have completed solving all the questions of question number 1. Okay, now let us move to question number 2. Okay, now let us quickly move on to the next question, that is question number 2. By applying remainder theorem, let us calculate and write the remainders that I shall get when the following polynomials are divided by x minus 1. Okay, when this expression is divided by x minus 1, what will be the remainder? Okay, the question is what will be the remainder when this expression is divided by x minus 1 and this expression is divided by x minus 1. We are asked to find the remainder applying remainder theorem. Okay, I hope you got this. Okay, let x minus 1 equals to 0, okay, or x equals to 1. X minus 1 equals to 0, x equals to 1. Means 0 of the polynomial x minus 1 is 1. Okay, 0 of the polynomial x minus 1 is 1. So let fx equals to x cubed minus 6x square plus 13x plus 60, isn't it? Fx, I am supposing this to be fx. Fx is this. So remainder will be f1. This is very simple, isn't it? Remainder will be f1. F1 equal to, instead of x we write, since fx is this, so f1 will be, instead of x we write 1. X cube means 1 cube minus 6, 1 square, instead of x we write 1 square plus 13, instead of this x we write 1 plus this 60. So 1 cube is 1 minus 1 squared is 1, 1 6 are 6 plus 13 ones are 13 plus 60. We add up all the positive numbers and subtract the negative one, okay? 60 plus 13 is 73, 73 plus 1 is 74, 74 minus 6 is 68, I think so, 68, 68 plus, yeah, 68, 68 plus 6, 74, yes. So when this expression is divided by x minus 1, the remainder will be 68. Let us quickly move on to the next question, that is this one, number 2. Take the screenshot, I am going to erase this. Okay. Okay. So we have let x minus 1 equal to 0, x equals to 1, 0 of the polynomial x minus 1 is, we copy this as it is here, okay. 0 of the polynomial x minus 1 is 1. So let fx equals to x cubed minus 3x square plus 4x plus 50, isn't it? So remainder will be f1. Are you getting me? Fx is this, remainder will be f1. F1 equal to, instead of x we write 1, okay? 1 cube minus 3, 1 square, okay, this 1 square, plus 4 into 1, oh, I didn't get enough space, let me start from there. Or f1 equal to, instead of x we write 1 cube minus 3, 1 square plus 4 into 1 plus 50. Okay, so 1 cube is 1, so 1 square is 1, 1 to 3 is 3, minus 3 plus 4 ones are 4 plus 50. 50 plus 4 is 54 plus 1 is 55, 55 minus 3 is 52, isn't it? So the remainder will be 52. So when this expression is divided by x minus 1, the remainder will be 52. Applying remainder theorem. Okay, let's go for another question, that is question number 3. Please take the screenshot of this. I am going to copy question number 3 here. Question number 3, we have 4x cubed plus 4x cubed plus 4x square minus x minus 1. Okay, 4x cubed plus 4x square minus x minus 1. This is question number 3. When this expression is divided by x minus 1, what will be the remainder? That is the question. Let x minus 1 equals to 0. Let x minus 1 equals to 0, or x equals to 1, isn't it? Minus 1 when you take to the right hand side becomes plus 1. So 0 of the polynomial x minus 1 is 1. Let fx equals to 4x cubed plus 4x square minus x minus 1. Are you getting me? So the remainder will be f1, isn't it? The 0 of the polynomial is 1, x equals to 1, so instead of x we write 1. 4x cubed means 1 cube plus 4x square means 1 square, isn't it? Minus x means 1 minus 1. Okay, 1 cube is 1, 1 into 4 is 4, plus 1 square is 1, 1 into 4 is 4, minus 1 becomes minus 2, 4 plus 4 is 8, and 8 minus 2 is 6. Sign of greater number comes, so the sign will be plus 6. So when this expression is divided by x minus 1, the remainder will be plus 6. This is how we calculate remainder by applying remainder theorem. Please take the screenshot of this. We will move on to question number 4, okay? Question number 4. Question number 4, we have 11x cube. 11x cube minus 12x square, 12x square minus x plus 7, isn't it? 11x cube minus 12x square minus x plus 7. So we are asked to divide this expression by this expression and find the remainder by applying remainder theorem, okay? Let x minus 1 equals to 0 or x equals to 1. The same thing again and again. 0 of the polynomial, x minus 1 is 1. Let fx equals to 11x cubed minus 12x squared minus x plus 7. 11x cubed minus 12x squared minus x plus 7. So remainder will be f1, isn't it, according to remainder theorem? So if you have not understood what is remainder theorem, I will remind you again. Please find the link below in the description and watch remainder theorem again to understand this, okay? So according to remainder theorem, f1 will be the remainder. So since fx is this, f1 will be, instead of x we write 1. 11 x means 1. 1 cube minus 12, instead of x we write 1 squared minus x means 1 plus 7, isn't it? So 1 cube is 1 and that 1 into 11 is 11, okay? Minus 1 squared is 1, then 1 into 12 is 12, minus 1, okay? Minus 1 plus 7 is plus 6, isn't it? 7 minus 1 is 6. So 6 and 11, okay, 12 minus 11 is minus 1, isn't it? 12 minus 11 is minus 1, and minus 1 plus 6 is plus 5. Are you getting me? Minus 12 plus 11, that is minus 1. Minus 1 plus 6 is plus 5. This is the remainder. When this expression is divided by x minus 1, the remainder will be 5. So we have completed question number 2 also. Now let us quickly move on to question number 3. Okay, in question number 3, applying remainder theorem, let us write the remainders when, question number 1, okay, sub number 1 of 3. The polynomial this is divided by this. When x cubed minus 6x squared plus 9x minus 8 is divided by x minus 3, what will be the remainder? We are asked to find the remainder by applying remainder theorem, okay? Let x minus 3 equal to 0 or x x equals to minus 3 when taken to the right hand side becomes plus 3. So 0 of the polynomial x minus 3 is 3. Got it? So let we have polynomial fx. Fx is x cube minus 6x squared plus 9x minus 8, isn't it? Now remainder will be f3, isn't it? Remainder will be f3. So since fx is this, so f3 will be, instead of x we put 3. We have x cube means 3 cube minus 6 x square means 3 square plus 9, and this x means 3, isn't it? Minus 8. Instead of x we write 3, okay, because we are finding the value of f3 and f3 is the remainder. 3 cube is 27, 3 multiplied 3 times, 3 squared is 9, 9 6 are 54, minus 54 plus 9 3 is 27 minus 8. This 27 when added to 27 becomes 54, isn't it? And plus 54 minus 54 becomes 0, so remains minus 8. So this means when this expression is divided by x minus 3, the remainder will be minus 8. I hope you got this. Now let us quickly move on to the next question, number 2. Number 2 is, please take the screenshot, I am going to erase this, okay. The polynomial number 2, the polynomial x cube minus ax square plus 2x minus a plus 2x minus a, okay. X cube minus ax square plus 2x minus a is divided by x minus a, is divided by x minus a. Okay. When the polynomial when this polynomial is divided by x minus a, what will be the remainder? And we are asked to apply remainder theorem to find the remainder when this divided by this, okay. Let x minus a equal to a, or sorry, let x minus a equal to 0, or x equal to minus a becomes plus a when taken to the right hand side, isn't it? So 0 of the polynomial, x minus a is a. Let the polynomial be fx. Fx is x cube minus ax square plus 2x minus a. So remainder will be fa, isn't it? Remainder will be fa, this a, fa. Since fx is this, so fa will be, instead of x we put a. X cube means a cube minus we have a here, and this x square means a square plus this 2 comes here. Instead of x we put a minus a, okay. So this is a cube minus comes here, a square into a becomes a cube plus 2 into a is 2a, and this is minus a, isn't it? Plus a cube and minus a cube becomes 0. 2a minus a is a, okay. 2a minus a is a. So when the expression this is divided by x minus a, we got the remainder a by applying remainder theorem, okay. So this is the end of question number 3. We will move on to question number 4 quickly, okay. Okay, let's quickly begin with question number 4. Applying remainder theorem, let us calculate whether the polynomial px equal to 4x cubed plus 4x squared minus x minus 1 is a multiple of 2x plus 1 or not. Okay, what the question says is, we are given with this polynomial 4x cubed plus 4x squared minus x minus 1, and the question is asking us to verify whether 2x plus 1 is a multiple of this expression or not. We are asked to verify whether 2x plus 1 is a multiple of this expression or not. Okay, let me tell you what multiple means. First, let us understand what multiple means. Okay, let me write a number here. This is 56, isn't it? This is 56, and suppose we have another number 8. Okay, and if I ask you whether 8 is multiple of 56 or not, okay, 8 is whether the multiple of 56 or not. To know this, what we usually do is we find the factors of 56, isn't it? 2 2s are 4, we have 1, this becomes 16, so 2 8s are 16, 2 1s are 2, 2 4s are 8, and 2 7s are 14, isn't it? 2 into 2 into 2 into 7 gives 56. 2 2s are 4, 4 2s are 8, 8 7s are 56. Here we have 2 2 2, this becomes 8 into 7. So in 56, in the number 56, we have the number 8 and the number 7. This means number 8 is multiple of 56 and number 7 is also multiple of 56. Okay, 8 is the multiple of 56. Okay, got this? Okay, to verify whether number 8 is multiple of 56 or not, we can do by this method, by finding the factors of 56, or simply by dividing with 8. Okay, are you getting my point? If I divide 56 by this 8 and if the remainder comes 0, then we can say 8 is the multiple of 56. And if the remainder is not 0, if the remainder does not come 0, then we can say 56 is 8 is not the multiple of 56. Okay, 8 7s are 56, isn't it? So the remainder here is 0. Since the remainder comes 0, so 8 is the multiple of 56. We do not do by this method. This is very, very simple. Okay, suppose if I ask you whether number 5 is the multiple of 56 or not. First, let us divide 56 by 5 and check whether the remainder comes 0 or not, and then we will be able to say 5 is the multiple of 56 or not. Let's multiply 5 1s are 5 and 0 comes here, this 6 here, 5 1s are 5 again, so 6 minus 5 is 1, so the remainder is 1 here, because this one is smaller than 5, so we cannot further divide, so remainder is 1 here. In this case, remainder is not 0, so we say 5 is not the multiple of 56, because when we divide the number 56 by 5, the remainder did not come 0. So to become a multiple of certain number, the remainder must come 0, which means to verify whether 2x plus 1 is a remainder of this expression or not, we must check by dividing this number by 2x plus 1, and if the remainder comes 0, then we can say 2x plus 1 is multiple of this expression, and if the remainder does not come 0, then we say 2x plus 1 is not the multiple of this expression. Okay, I hope you got this. Okay, by applying remainder theorem, we are doing by applying remainder theorem, we do not divide by the traditional algebraic division method, okay, a usual division method. Let 2x plus 1 equal to 0. In this case, x equals to plus 1 when taken to the right hand side becomes minus 1, and this 2 comes in the denominator, isn't it? X equals to minus 1 upon 2. So 0 of the polynomial 2x plus 1 is minus 1 upon 2, isn't it? 0 of the polynomial 2x plus 1 is minus 1 upon 2. Px, no, we need not suppose, there is already px. Px equal to, since px equal to 4x cubed plus 4x square minus x minus 1. Now if p minus 1 upon 2, that is the remainder, isn't it, by applying remainder theorem, p minus 1 upon 2 comes 0, then we can say 2x plus 1 is the multiple of this expression. Okay, then remainder will be, according to remainder theorem, remainder will be p minus 1 by 2, isn't it? Remainder will be p minus 1 by 2. Minus 1 by 2. P minus 1 by 2 will be the remainder. Okay. If you have no idea about this, please check the remainder theorem. Find the link below in the description. Okay. So, since we have px is this expression, so p minus 1 by 2 is, whenever we see x, we put minus 1 by 2. Okay. 4 into x means minus 1 by 2 whole cubed plus 4 into x means minus 1 by 2 whole square, isn't it? Minus x means minus 1 by 2 and minus 1. Got it? So 1 cubed is 1. Let us first check our sign. Okay, since the power is odd number, the sign will remain minus, so minus into plus will become minus, isn't it? Power is odd number, this 3 is odd, so the sign will remain minus. This minus into plus is minus, so 1 cubed is 1, and that 1 into 4 is 4, divided by 2 cubed is 8. Okay, now this power is even, 2 is even number, so this sign changes to plus. Plus into plus becomes plus. 1 squared is 1. 1 into 4 is 4. Divided by 2 squared is 4. 2 to the 4. Okay, minus into minus is plus, and 1 by 2. Minus 1. Minus 1 by 2. Minus into minus plus 1 by 2, and this minus 1 comes here. Okay. Excuse me. Let me continue this. Please take the screenshot. So minus 4 1 the 4, 4 2 the 8. This becomes minus 1 by 2, isn't it? 4 1 the 4, 4 2 the 8. Minus 1 upon 2. This 4 and this 4 cancelled. Here is 1. So plus 1 plus 1 plus 1 by 2 plus 1 by 2, and this is minus 1. Minus 1. This plus, this is p minus 1 by 2, isn't it? P minus 1 by 2 equals to this plus 1 and this minus 1 becomes 0. This plus half and minus half also becomes 0. Therefore, p minus 1 by 2, which is the remainder, equals to 0. Okay. Since the remainder came 0, so the expression when divided by 4x cubed plus 4x squared minus x minus 1, when this expression divided by the expression 2x plus 1, isn't it? We have 2x plus 1. When this expression divided by this expression, the remainder came 0. This means this 2x plus 1 is multiple of 4x cubed plus 4x squared minus x minus 1. Therefore, we can say 2x plus 1 is a multiple of 4x cubed plus 4x squared minus x minus 1. Got my point? If the remainder here is not 0, if the remainder was suppose another number other than 0, then 2x plus 1 would never be the multiple of this expression. Got my point? Okay, let's go for another question. Okay, we are ready to go for question number 5. For what value of a, the divisions of two polynomials ax cubed plus 3x squared minus 3 and 2x cubed minus 5x plus a by x minus 4 give the same remainder. Okay, the question is, for what value of a, when this is divided by this, gives a certain remainder, isn't it? when this expression is divided by x minus 4 gives a certain remainder, and this expression divided by x minus 4 also gives certain remainder. Question is, for what values of a, the remainder will be same in both the cases, means remainder will be equal. Okay, the remainder will be equal. Okay, when this divided by this, we get some remainder, and when this divided by this also, we get another remainder, isn't it? So for what value of a, the two remainders will be equal? The question is that. Now how will we solve this? How do we do this? First we find the remainder when this divided by this, and we again find the remainder when this divided by this. Okay, and we equate the remainder. After that we equate the remainder and we will find the value of a. Okay, let x minus 4 equals to 0 or x equals to 4. 0 of the polynomial x minus 4 equals to is 4. 0 of the polynomial x minus 4 is 4. So let fx equal to ax cube plus 3x square minus 3. Ax cube plus 3x square minus 3. Okay, now remainder will be f4, isn't it? So instead of x we write 4. A 4 cube plus 3 4 square minus 3. A 4 cube means 4 4s are 16, 16 4s are 64, isn't it? Into 64. 4 4s are 16, 16 4s are 64. Plus 4 4s are 16, 4 square means 16, 16 3s are 48. Minus 3. Okay. 64 into a is 64a plus 48 minus 3 is 45. Got my point? When this expression is divided by x minus 4, we got remainder 64a plus 45. Okay. Now let us check, when this is divided by x minus 4, what will be the remainder? Okay. Let x minus 4 equal to 0 or x equal to 4. Therefore 0 of the polynomial x minus 4 is 4. So let fx equal to 2x cube minus 5x plus a. So remainder will be f4, isn't it? Instead of x we write 4 now. 2x means 4 cube minus 5x means 4 plus a. 4 cube means 64, 64 2s are 2 4s are 8, 2 6 are 12, 128 minus 5 4s are 20 plus a. 8 minus 0 is 8, 2 minus 2 is 0, and this one comes here plus a. Okay, when we divide this by x minus 4, we got remainder 108 plus a. And according to the question, this remainder and this remainder are equal. Okay, these two remainders are equal according to question, isn't it? Let me continue from here. Okay, since according to question, according to condition, or you can add question, two remainders are equal, isn't it? 64a plus 45 equal to 108 plus a, or bring this a to the left hand side and take this 45 to the right hand side. 64a minus a equal to 108 minus 45, plus a becomes minus a and plus 45 becomes minus 45, or this becomes 63a, 64a minus 1a is 63a equal to 108 minus 45. 8 minus 5 is 3. This becomes 10 minus 4 is 6, okay, or a equal to 63 upon this 63 comes in the denominator. Let us cancel this and a equals to 1, okay. So for what value of a, this expression when divided by x minus 4 and this expression when divided by x minus 4 gives equal remainder. The question was that, and we got for a equal to 1, when the value of a is 1, this expression when divided by this will give the remainder which is equal to when this divided by this, okay. Got my point? Okay, let us quickly move on to the next question, that is question number 6. Okay, the two polynomials x cube plus 2x square minus px minus 7 and x cube plus px square minus 12x plus 6 are divided by x plus 1 and x minus 2 respectively, and if the remainders are r1 and r2 are obtained, r1 and r2 are obtained, and if 2r1 plus r2 equals to 6, then let us calculate the value of p. Okay, let me explain you. If this expression is divided by x plus 1, we get the remainder r1, okay. When this expression x cube plus 2x square minus px minus 7 is divided by x plus 1, we get the remainder r1. And when this expression x cube plus px square minus 12x plus 6 is divided by x minus 2, we get the remainder r2, okay. Got my point? And condition is 2r1 plus r2 equals to 6. When we add the remainders in this way, 2 times the remainder in the first case plus remainder in the second case equals to 6. This is the given equation. If this is the condition, then what is the value of p? We are asked to find the value of p. Okay, let us first check the remainder when this expression is divided by x plus 1, okay. Let x plus 1 equal to 0, x plus 1 equal to 0, or x equals to minus 1. Therefore 0 of the polynomial x plus 1 is minus 1, isn't it? So we have let fx equals to this expression x cube plus 2x square minus px minus 7. When this expression is divided by x plus 1, what will be the remainder? We are finding the remainder, okay. So remainder will be f minus 1, remainder will be f minus 1, isn't it? F minus 1 will be the remainder. F minus 1 equals to, wherever we see x, we put minus 1. So minus 1 whole cubed plus 2, x means minus 1 whole squared minus p into x means minus 1 minus 7, isn't it? X cube means minus 1 whole cube plus 2x square means 2x square means minus 1 whole square, this minus here, p means p, x means minus 1 minus 7, okay. So 1 cube means 1, since the power is odd we put minus sign here. Since the power is even, this sign changes to plus, so plus into plus becomes plus. 1 squared is 1, 1 into 2 is 2. Minus into minus is plus, p into 1 is p, minus 7. So minus 7 plus 2 and minus 1, we calculate this number separately and keep this p separately, okay. So 2 minus 1 becomes plus 1 and minus 7 plus 1 is minus 6, isn't it? So this is plus p this is plus p, minus 7, minus 1, minus 8, plus 2, minus 6. Got my point? P minus 6. But the question says when we divide this by this, the remainder will be R1. That means the remainder, this is R1, isn't it? So R1 equals to this. Got my point? R1 equals to this, because when we divide this expression by this, whatever be the remainder, that remainder is R1. So R1 is equal to this. So please copy this. I'm going to erase this, okay, the upper part, and I'm going to copy this here so that I may use later on. R1 equal to P minus 6, isn't it? P minus 6. Okay, now let us see when this expression is divided by this expression, what will be the remainder? We are trying to find out, okay? I'm going to erase this. Please take the screenshot. Let x minus 2 equals to 0, because we are dividing this expression by this and finding the remainder. So let x minus 2 equals to 0, or x equals to minus 2 when taken to the right hand side becomes plus 2. Therefore 0 of the polynomial x minus 2 is 2. So let fx equals to x cube plus px square minus 12x plus 6. X cube plus px square minus 12x plus 6. X cube plus px square minus 12x plus 6. Okay. So the remainder will be f2, because the 0 polynomial is 2. So remainder will be f2, isn't it? Remainder will be f2. So wherever we see x, we put 2. X cubed means 2 cubed plus p x square means 2 square minus 12. X means 2 plus 6, isn't it? So 2 cubed is 2 2 is 4, 4 2 is 8, plus 2 square means 4, 4 into p is 4p, minus 12 2 is 24, isn't it? So plus 6. 8 plus 6 14, plus 8 plus 6 14, 14 minus 24 is minus 10, isn't it? So 4p minus 6 plus 8 14, 24 minus 14 is minus 10. 10 plus 14 is 24, isn't it? So 24 has minus sign, the sign of greater number comes here. So when this expression is divided by x minus 2, we got the remainder this. But according to question, when this expression is divided by x minus 2, the remainder should be R2. So that this means R2 equals to this. R2 is equal to this. R2 equals to 4p minus 10. Are you getting my point? R2 equal to 4p minus 10. So now we have this equation, 2r1 plus r2 equals to 6. This is given, isn't it? From here we are asked to find the value of p. Okay, since according to question, okay, according to question, this is given to us. According to question, since 2r1 plus r2 equal to 6, isn't it? 2r1 plus r2 equals to 6. This is given condition. So 2, we write 2, r1. r1 means p minus 6. p minus 6 plus r2. r2 means 4p minus 10. 4p minus 10 equal to 6. Or 2 into p is 2p minus 2 6 are 12 plus 4p minus 10 equal to 6 plus 10 minus 10. Let's transpose it to the right hand side. Okay, 2p plus 4p is 6p. 6 plus 10 is 16. 16 plus minus 12, let us take to the right hand side, becomes plus 12. Okay, 4p plus 2p 6p. 6 plus 10 is 16 in the right hand side. Now minus 12 when we take to the right hand side becomes plus 12, or p equals to 16 plus 12. 6 plus 2 is 8. 1 plus 1 is 2 divided by 6, isn't it? So 2 3s are 6, 2 1s are 2, 2 4s are 8. 14 upon 3, or p equals to 14 upon 3. And this is an improper fraction because 3 is lesser than 14 and 3 is in the denominator. So we must convert this type of fraction into mixed fraction, isn't it? So let us divide 14 by 3. 3 4s are 12. 3 5s are 15. So we must take 3 4s are 12. 4 minus 2 is 2. Okay. So the value of p is 4 whole. Quotient will be here 4 and 2 upon 3. This is the value of p. We were asked to find the value of p, so the value of p is 4 whole 2 upon 3. I hope you got this, understood this. Okay, now let's go to the next question, and that question is number 7. Okay, let's read out the question first and then understand. If the polynomial x to the power 4 minus 2x cubed plus 3x squared minus ax plus b is divided by x minus 1 and x plus 1, and the remainders are 5 and 19 respectively, but if that polynomial is divided by x plus 2, then what will be the remainder? Okay, let's understand the question. The question is very, very simple. Okay, let me make you understand. When this expression is divided by x minus 1, we will get a certain remainder, isn't it? And the question says that remainder equals to 5. Got my point? When this expression is divided by x minus 1, we will get a certain remainder, and that remainder equals to 5. Okay? And the second condition is when this expression is divided by x plus 1, we get another remainder, and that remainder equals to 19. Okay? Now the question is asking, what will be the value of the remainder when this expression is divided by x plus 2? Got my point? I hope you understood. What will be the remainder when this expression is divided by x plus 2? First, what we do is we calculate the value of a and b. How? When we divide this expression by x minus 1, we get a certain remainder, and that remainder equals to 5. That is equation 1. And in the second case, when we divide this expression by x plus 1, we get a certain remainder, and that remainder equals to 19. That is equation 2. From equation 1 and 2, we calculate the value of a and b, and that value we put in this expression, the value of a and b. When we put the value of a and b in this expression, this expression will now have only the variable x and the numbers. Okay, no a and b. And from that, when we get that expression, when we divide that expression by x plus 2, we get a remainder, and that is what the question is asking to us. Let's begin. Okay, I hope you got the question, understand the question. Okay, let's move. Okay, x minus 1. Let x minus 1 equals to 0. We are dividing this expression by x minus 1. Okay, so x minus 1 equals to 0, or x equals to minus 1 becomes plus 1 when we take to the right hand side. Now 0 of the polynomial x minus 1 is 1, isn't it? X minus 1 is 1. So let fx equal to x to the power 4 minus 2x cubed plus 3x squared minus ax plus b. Okay, now remainder will be, we know that we have calculated many sums, isn't it? We have done many sums. Remainder will be f1, isn't it? The remainder will be f1. So we put 1 instead of x in this expression. X is 1, 1 to the power 4 minus 2, x is 1, 1 cubed plus 3, x square means 1 square minus a into x means 1 plus b. 1 to the power 4 means 1 multiplied 4 times, that is 1. 1 cube means 1 multiplied 3 times, that is 1. And 1 into 2 is 2, so minus 2 plus 1 square means 1 into 1. 1 into 1, 1 multiplied 2 times. 1 into 1 is 1, and 1 into 3 becomes 3. Minus a into 1 is a plus b. Okay. Now we have 3 and 1, a positive number, plus 3 plus 1, 4. 4 minus 2 is 2. 2 minus a plus b. 2 minus a plus b. Okay. 2 minus a plus b. But the question has given us the remainder 5. When we divide this expression by x minus 1, we got this remainder, isn't it? But the question has already provided that when this expression is divided by x minus 1, the remainder will be 5. Okay. This means this expression equals to 5, isn't it? This is the remainder. So therefore, so let me write here. Please copy this part. Okay, let me continue here. So 5 equals to this, isn't it? So 2 minus a plus b equals to 5, because when we divided this expression by x minus 1, we got this remainder, and the question has provided when this expression is divided by x minus 1, the remainder will be 5. So this remainder and 5 are equal because they are the same remainders. So minus a plus b equals to plus 2. When we take to the right hand side, becomes minus 2, isn't it? Plus 2 becomes minus 2. Minus a plus b remains in the left hand side as it is, or minus a plus b equals to 5 minus 2 is 3, isn't it? This is equation 1. Okay. Minus a plus b equal to 3. This is equation 1. Now please take a screenshot of this part. I'm going to erase this and continue the second part. Okay. Okay. So when we divide this expression by x plus 1, we get a certain remainder, and that remainder equals to 9, 10 according to question. Okay. Let x plus 1 equals to 0, or x equals to plus 1 becomes minus 1 when taken to the right hand side. So 0 of the polynomial x plus 1 is minus 1. Got my point? So let fx equals to x to the power 4, x to the power 4 minus 2x cubed plus 3x squared minus ax plus b. Okay. Therefore, our remainder will be f minus 1, isn't it? F minus 1 will be the remainder. So wherever we see x, we put minus 1. X to the power 4 means minus 1 to the power 4 minus 2 x cube means minus 1 cube plus 3x square means 3 minus 1 square minus ax means minus a, x means minus 1 plus b. Okay. So this 4 is even number, and if the power is even, this minus sign changes to plus. Okay. So plus, now the sign becomes plus. So 1 to the power 4 means 1 multiplied 4 times. 1 into 1 into 1 into 1 becomes 1. Now the power is odd number, the sign will remain minus. Okay, minus into this minus is plus. 1 cubed means 1 into 1 into 1. So 1 into 1 into 1 is 1. So 1 into 2 becomes 2. Now this power is even number, this sign changes to plus, and this plus to plus, plus into plus is plus, 1 square is 1, 1 into 3 becomes 3, minus into minus is plus, a into 1 is a plus b, okay. Now we have 3 plus 2, 5 plus 1, 6 plus a plus b, isn't it? 6 plus a plus b, okay. But according to the question, when this expression is divided by x plus 1, the remainder should be 19. That means this remainder we got by dividing this expression by x plus 1, isn't it? So this means this remainder and 19 should be equal. So 19 equals to this according to question, okay. Or let me write in this way, 6a plus b, 6 plus a plus b, 6 plus a plus b equal to 19, okay. Or a plus b equal to 19 minus 6, or a plus b equal to, this plus 6 when taken to the right side, it becomes minus 6, okay. 19 minus 6, 9 minus 6 is 3, and this is 1. A plus b is 13. This is equation 2. We have equation 1 minus a plus b is 3, and equation 2 a plus b is 13, okay. Now let us solve equation 1 and 2 and find the values of a and b, and then we will put that value in equation in this expression, okay. Okay, since minus a plus b equals to 3, isn't it? And we have a plus b equal to 13. This is equation 1, this is equation 2. We have learned to solve simultaneous equation. Please find the link below in the description and watch the simultaneous equation. We have already done that chapter in our previous video, okay. Now adding equation 1 and 2, what do we get? Minus a and plus a cancels out, becomes 0. B plus b is 2b equal to 13 plus 3 is 16, isn't it? So or b equal to 2 8 is 16, okay. B 2 comes to the denominator, 2 into 8 is 16, b is 8. Similarly, we will find the value of a. Putting the value of b in equation 1 or 2, okay. Putting the value of a in equation 1, okay. My equation 1 is minus a plus b equal to 3, isn't it? So or minus a plus b means 8 equal to 3, or minus a equal to 3 plus 8 we take to the right hand side becomes minus 8, or minus a equal to minus 5. Minus 8 plus 3 becomes minus 5, minus minus gets cancelled, so a equals to 5. A equals to 5. We have b equal to 8 and a equal to 5. Now let us put this value of a and b in this expression, okay. Let me erase this, okay. Take the screenshot of this. Okay, we have the expression x to the power 4 minus 2x cube plus 3x square minus ax plus b, isn't it? So we put the value of a and b. What was the value of b? Value of b was 8, isn't it? And value of a is 5. X to the power 4 minus, let us write here, putting the value of a and b, okay. X to the power 4 minus 2x cube plus 3x square minus a means 5, 5x plus b means 8, okay. We just put the value of a and b in the expression, above expression which was given. Now when this expression is divided by x plus 2, what will be the remainder, okay. That remainder is the answer to this question, okay. we are asked to find that remainder when this expression is divided by x plus 2. Okay, since x plus 2 equals to 0 or x equals to plus 2 becomes minus 2, 0 of the polynomial x plus 2 is minus 2, isn't it? So let fx equal to x to the power 4 minus 2x cubed plus 3x squared minus 5x plus 8. Therefore remainder that is f minus 2, isn't it? F minus 2. Remainder will be x. Wherever we see x, we put minus 2. Since fx is this, so f minus 2 will be minus 2 whole to the power 4 minus 2x means minus 2 whole cube plus 3x square means minus 2 squared. Again minus 5x means minus 2 plus 8. Okay, this power is even, so this minus sign changes to plus. 2 to the power 4 means 2 multiplied 4 times. 2 to the 4, 4 to the 8, 8 to the 16. Okay, 2 multiplied 4 times. 2 into 2 into 2 into 2. 2 to the 4, 4 to the 8, 8 to the 16. Okay, 16. Now since this power is odd, this is 3. 3 is odd number, so sign will remain minus. Minus into this minus is plus. 2 cubed is 8. 2 into 2 into 2. 2 into 2 into 2. This is 8. Okay. 8 into 2 is 16. Okay. Plus. This is even number, so sign will become plus. Minus square means plus. Plus into plus is plus. So 2 square is 4. 4 3s are 12. Minus into minus is plus. 5 2s are 10 plus 8. Okay. Now all the numbers are positive, so we need to add all the numbers. 16 plus 16 plus 12 plus 10 plus 8. Okay. 6 plus 6 12, 12 plus 2 14, 14 plus 0 14 plus 8 is 22. 22 means 2 in hand, so 1 plus 2 3 4 5 6 62, isn't it? Let me write properly. 62. 16 16 32, 32 plus 10 42, 42 plus 12 54, 54 plus 8 62. Okay, this is the remainder. Okay, when this expression is divided by x plus 2, the remainder will be x plus 2. First we found the value of a and b. Okay, and then we just put the value of a and b in this expression. After that we divided by x plus 2 and got the remainder 62. I hope you understood this. Okay, now let's go for question number 8. Okay, if fx equals to this, then let us show that fa plus fb equal to fa plus b. We are given the value of fx, this. Now we are asked to prove this relation, fa plus fb equals to fa plus b. Okay, this is very simple. First what we do is we will find the value of fa from this relation. We will find the value of fa and then we will find the value of fb. Okay, then again we will find the value of fa plus b and check the left hand side and the right hand side of this equation. If the value comes equal, then this equation will be proved. Okay, let's begin. Since fx is this, so we need to find the value of fa. So fa, since fx is this, no need to write. Okay, I will just write since here. So fa will be wherever we see x, we put a. Okay, a, x means a minus b divided by a minus b plus b. X means a, because we are finding fa, isn't it? X means a minus a upon b minus a. So this a minus b is in the denominator and a minus b in the numerator, so a minus b and a minus b can be cancelled. So our fa equals to a, this a is here, so this is a minus a is 0, a minus a is 0, 0 into b is 0, and 0 divided by b minus a is 0. A plus 0, a plus 0 comes here, and a plus 0 is a, isn't it? So fa is a, we got the value of fa, okay? Now we will find the value of fb, okay? Let me write that value here. Fa equal to a. This is the first thing we got, the value of fa as a. The value of fa is a. Okay, now we will find the value of fb, okay? Let me erase this. We will find the value of fb from this relation. Fb equals to, wherever we see x, we put b, okay? A, x means b minus b upon a minus b plus b upon x means b minus a upon b minus a, isn't it? So this b minus a and b minus a can be cancelled. Fb equals to, this b minus b is 0, 0 into a is 0, 0 divided by a minus b becomes 0, and that 0 plus b is b. Are you getting my point? I hope you got. B minus b is 0, isn't it? That 0 into a is 0. So 0 in the numerator divided by a minus b in the denominator. If 0 is in the numerator, no matter whichever number be in the denominator, the value is always 0. So 0 plus b will become b. That means fv, we got fv equals to b. Okay, fa and fv, we found the value. Now we will find the value of fa plus b. Okay, let me erase this. We will find the value of fa plus b. Fa plus b. Okay, wherever we see x, we will put a plus b, okay? And this is a, x means a plus b minus b. This x means a plus b and minus b. We already have this, we should not remove that. In the denominator we have a minus b plus b is b. Instead of this x, we are going to write a plus b minus this a. We should not forget that a, okay? So b minus a is in the denominator. Now from here, this plus b and minus b can be cancelled. So a into a is a square in the numerator. In the denominator we have a minus b plus this plus a and minus a can be cancelled. So b into b is b square. So b minus a in the denominator. Got my point? So we can take this minus sign from the denominator common, okay? Please understand this, okay? A square upon a minus b. Let me show you here. We have b minus a, isn't it? We have b minus a. If we take minus sign common from here, what happens is this minus a will change to plus a and this plus b will change to minus b, okay? When we take minus sign common out, because if we multiply this, we should get this one, okay? Minus into plus a becomes minus a, minus into minus b becomes plus b. Are you getting my point? So if I take minus common from the denominator, minus common from the denominator, minus and multiply with this plus, minus into plus is becomes minus upon b square upon, now this b minus a becomes a minus b. Why am I taking the common out? Is to just make the same like this. We have a minus b here. Just to make a minus b, I took minus sign common and multiplied with this plus sign and wrote this minus, okay? Okay, now this minus a minus b and a minus b, the LCM of the a minus b and a minus b is a minus b. I hope you are getting me, okay? The LCM of a minus b and a minus b is a minus b. So in the numerator we have a square minus b square, isn't it? So a square minus b square is formula a plus b into a minus b, isn't it? So a minus b we have in the denominator, isn't it? A square minus b square is a plus b, a minus b. This is formula, okay? And this a minus b we already have in the denominator, so this can be cancelled, a minus b, a minus b. So this is a plus b, okay? So f a plus b equals to a plus b, isn't it? Now let us prove this, okay? Let me erase this and prove here. In the left hand side we have fa plus fv. We have fa plus fv, isn't it? So fa means a plus fv means b. We got a plus b. In the right hand side we have fa plus b, isn't it? fa plus b, and the value of fa plus b is a plus b. So left hand side also a plus b and right hand side also a plus b. This means left hand side equals to right hand side, isn't it? Hence it is proved. Understood? I hope you understood. Okay, now let's quickly move on to the next question, that is question number 9. And if fx equal to ax plus b, this is given to us. This is a polynomial fx equals to ax plus b. And we are given f0 is 3 and f2 is 5. Okay, f0 is 3 and f2 is 5. Then let us determine the values of a and b. Means we are asked to find the value of a and b. If f0 is 3 and f2 is 5, then what are the values of a and b? Okay. Now let us find the value of f0. Since fx equal to ax plus b, or f0, okay, we are finding the value of f0. f0 equal to, instead of x we write 0, isn't it? A into 0 plus b, or f0 means a into 0 is 0, 0 plus b is b. We got f0 equals to b. f0 means we got b, okay? Now we will find f2, okay? Oh, and f0 means 3, isn't it? So b equals to 3. b equals to 3. f0 means 3. It is given to us. Since f0 equals to 3, this is given to us. f0 is equal to 3. So b, f0 means b. b equals to 3. f0 equals to b. f0 means 3. So b equals to 3. Okay. And the second condition, f2. Since fx equals to ax plus b. fx equal to ax plus b, or f2. f2 means a into 2 plus b, or f2, the value of f2 is given to us, 5. f2 means 5, given. This is given. f2 means 5 equal to 2 into a, 2a plus b, or 5 equal to 2a plus b means we have 3, isn't it? b means 3, or 5 plus 3 becomes minus 3 equals to 2a, or a equals to 5 minus 3 is 2. Upon this 2 comes in the denominator, 2 and 2 cancels out, or a equals to 1. Therefore the value of a is 1 and the value of b is 3. Okay, therefore a equals to 1 and b equals to 3. We were asked to find the value of a and b. The values of a and b are 1 and 3. Okay, question number 10, the last question from this exercise. Okay, let's do this. If fx equal to ax square plus bx plus c, and f0 equal to 2, f1 equals to 1 and f4 equals to 6. Then let us calculate the values of a, b and c. Okay, this expression is given to us and we are provided with the value of f0, that is 2, f1 1, f4 is 6. We are asked to find the value of a, b and c. Let me tell you again. The value of f0 is 2, f1 is 1, f4 is 6. This is given to us, okay? And we are asked to find the value of a, b and c. Very, very simple, okay? Let's do. Since fx equal to ax square plus bx plus c. This is given expression, okay? Now, let us find f0. F0 means, since fx is this, so f0 means wherever we see x, we put 0, isn't it? X means 0 square plus b, x means 0 plus c, okay? Or f0 equals to 0 squared means 0, 0 into a means 0, isn't it? So we have 0 here, b into 0 means 0. So 0 plus 0 is 0, isn't it? So that 0 plus c means c. I hope you got me. 0 squared means 0. 0 into a is 0. So this term becomes 0. So b into 0 means 0. This term is also 0. 0 plus 0 is 0. So 0 plus c means c. I hope you got this. f0 means c, isn't it? But we are provided with the value of f0, that is 2. The value of f0 is 2. So f0 is c and f0 is 2 according to question. Therefore, c means c equals to 2. Isn't it? f0 means 2. But we have found that f0 equals to c. f0 same. So c must be equals to 2. So the value of c is 2. We were asked to find the value of a, b and c. We have already found the value of c. C is 2. Let me write the value of c here, 2 separately, so we can use this later on, okay? I will erase this part. Please take the screenshot. We already found the value of c. Now we will proceed further to find the value of a and b, okay? f1, since f1 equal to a, instead of x we write 1 now, okay? 1 square plus b, x means 1 plus c. Or f1 equals to 1 square means 1, 1 ones are 1, 1 into a is a plus b into 1 is b plus c, isn't it? C means 2. C means 2. We write since c equals to 2. We have already found the value of c. C is 2, so we do 2 here. And again, the value of f1 is already given to us. f1 means 1. So this must be equal to 1 because f1 is this and f1 means 1. This means this must be equal to 1. So we can write therefore a plus b plus 2 equals to 1. I hope you got this. Or a plus b equals to 1 plus 2. When you take to the right hand side becomes minus 2. A plus b equals to minus 2 plus 1 becomes minus 1. This is equation 1, okay? This is equation 1. A plus b equals to minus 1. We will use this later on, so let me write here. A plus b equals to minus 1. This is equation 1. A plus b equals to minus 1. Equation 1, okay? Now let us find the value of f4, okay? f4. Since fx is this, so f4 means a, x means 4 square plus b into x means 4 plus c, isn't it? So, or f4 equals to 4 square means 16 into a means 16a plus b into 4 is 4b plus c means 2. C means 2. Since c equals to 2, we already have the value of c. But f4, the value of f4 given to us is 6. And the value of f4 we found this. That means this must be equal to 6. Therefore, 16a plus 4b plus 2 must be equal to 6, isn't it? Or 16a plus 4b equals to 6, you plus 2 when taken to the right hand side becomes minus 2, or 16a plus 4b equals to 6 minus 2 is 4, isn't it? So all these numbers are divisible by 4, so we can reduce the value by dividing throughout the equation by 4. Okay, when we divide the whole equation from left hand side to the right hand side by same number, the value of the equation does not change. Okay, so we can divide the whole equation by 4. 4 1s are 4, 4 4s are 16, 4 and 4 cancelled, 4 and 4 cancelled, we have 1 here. Okay, now 4 into a is 4a, plus we have only 1 here, 1 into b is b, equal to 1. This is equation 2. So 4a plus b equals to 1. This is equation 2, and equation 1 we already have, a plus b equals to minus 1. Let us solve equation 1 and 2 and find the value of a and b. Okay, let me erase this now, it's of no use. Okay, let us subtract equation 2 from equation 1. Okay, a plus b equal to minus 1. This is equation 1, isn't it? Equation 2 we have 4a plus b equal to 1. This is equation 2. Subtracting, when we subtract we have to change the sign. This plus 4a becomes minus 4a, plus b becomes minus b, plus 1 becomes minus 1. Okay, minus 4a and plus a becomes minus 3a. 4a minus a is 3a, sign of greater number comes here. Plus b and minus b cancels out, so this is minus 1 and this is minus 1, so minus 1 and minus 1 is minus 2. This minus and this minus cancels out, a equals to 2 upon this 3 comes in the denominator. So we found the value of a as well, we already have the value of c. Now the only thing is b, we need to find the value of b now. Okay, putting the value of a, putting the value of a in equation 1. You can put the value of a in equation 2 as well to find the value of b. Okay, a plus b equals to minus 1. We have a plus b equals to minus 1. That's equation 1. Let me put the value of a. A is 2 upon 3, isn't it? A means 2 upon 3 plus b equals to minus 1. Let me continue here. Plus b or plus b equals to, we already have minus 1 in the right hand side, plus 2 upon 3. When we take this number to the right hand side becomes minus 2 upon 3, isn't it? We have 1 in the denominator, so b equals to LCM of 1 and 3 is 3. 3 into 1 is 3, that is minus 3, minus here 1 into 2 is 2, or b equals to minus 3 and minus 2 is minus 5. Same sign, number adds up, but the sign will remain minus. Okay, upon 3. So we were asked to find the values of a, b and c, isn't it? We were asked to find the values of a, b and c. So we have a equals to 2 upon 3, a equals to 2 upon 3, b equals to minus 5 upon 3, minus 5 upon 3, and c equals to 2, isn't it? Okay, this is the answer for the last question of this exercise, question number 10. Okay, the value of a is 2 upon 3, b is minus 5 upon 3, and c is 2. I hope you got this. Okay, this was the last question from this exercise, question number 10. Okay, we have completed all the questions from this exercise, right from question number 1 to 10. I hope you understood the concept of the chapter. I want you to understand the concept of the chapter, not the sums. I hope you understood the concept of the chapter, and I will definitely continue this video with the MCQs of the remaining part of this chapter. Okay, the MCQs will be uploaded in the next video. Stay tuned follow the channel. Thank you so much for watching this video, and stay safe and be happy, because happiness is directly proportional to the positive energy. The more happy you become, the more positive energy you will get, and the more positive energy you have, the more intelligent you become. Remember the formula, so be happy. Thank you.